Good morning, all of you. Today I am going to present before you uh, my paper on future challenges in Indian power sector and including the remedial actions. As we all know that the Government of India has set an ambitious target of capacity achievement of 175 gigawatt by 2022. So this presents a set of challenges before us for Indian power sector associated with this much capacity addition. So I'll discuss few of the challenges in my paper. So the first challenge arises from this much huge amount of capacity addition itself. As we know that the RES capacity as on 31st March was only around 57 gigawatt. But this much capacity needs to be tripled within a duration of 5 years. So this requires a lot of huge fund requirement of around 6,48,000 crores. And to fund this much requirement, the funding sources can be scheduled commercial banks and financial institutions like PFC, REC, etc. But the main problem is that the banks and institutions are mired with issues of mounting burden of NPAs and fiscal bailout of DISCOMs. State finances are also constrained for giving consistent subsidies or grants for the projects. For the existing projects also, if we see that the solar power bid tariff has been consistently decreasing over the last few years. In fact, in the last quoted, it came to a low of 2.44 per kWh in the Bhatla solar park in Rajasthan. So we see that the competition has been getting severe due to the number of players which are in the field have increased, which has resulted into falling profit margins and return on capital employed. Along with that, there have been several risks associated with it, like non-payment of dues for power purchased, refusal of utilities to offtake power, and the states are also deferring their power procurement plants from RES to benefit from this trend of decreasing prices. Government on its part has taken several initiatives to make this sector lucrative, like providing fiscal incentives and subsidies in the form of viability gap funding from National Clean Energy Fund and accelerated depreciation. Payment Security Fund has also been provided to ensure visibility of cash flows for solar developers through Solar Energy Corporation of India against defaults by state distribution companies. National Tariff Policy 2016 has also been formulated, which has mandated solar RPOs to increase to 8% by 2022. Now, if we see the effectiveness of these initiatives, there have been reports of delays in signing of PPAs, delays in payments of commissioned plants, and forced reduction, shutdown of their power plants by RES developers. Analyzing the possible reasons, they may be lack of enforcement of RPOs by state regulators and poor financial health and credit worthiness of the utilities. Other than that, if we see the integration of the grid, which itself is a huge challenge, and that will also require huge capital infusion for strengthening of the transmission and sub-transmission networks. One more challenge is regarding the mismatch in the gestation period of RES generation and transmission capacities. Transmission line gestation varies from 3 to 4 years generally, but the gestation period of installation of RE-based generator is between 12 to 18 months. So this may create a scenario where RE-based generator would be available for power dispatch, but corresponding transmission line won't be available. So this may lead to bottlenecking of power of the plant and the plant being forced to shut down. Regarding the solar rooftops, we are also having a challenge because cost dynamics are still not conducive for the solar rooftops in Indian context due to frequent power disruptions, as storage batteries are also required for their utilization. Distribution and sub-transmission levels also need to be strengthened for encouraging solar rooftops. Net metering for the promotion of solar rooftops has been introduced, but solar rooftops installation is still not gaining enough traction. Other than that, the uncertainty and variability associated with RES generation always poses a serious challenge to the integrity, security, and reliability of the grid. few suggestions like for funding, we can have green bonds, climate bonds to fund these capital requirement of these projects, and comprehensive regulations related to net metering, time differentiated tariff, and regulations for ancillary services may be formulated soon. Multifaceted planning of grid integration of the RES capacity, considering all associated factors and contingencies to provide bottlenecking of power. Cooperation of states is also required, and interstate and intrastate transmission corridors need to be laid for evacuation of power from RE-rich states to the load centers. In this regard, Green Energy Corridor project is highly commendable. So in the last presentation, you would have seen this curve. So there's a variability and uncertainty associated with the RE generation, as told in the last presentation. So generation from the solar is highly variable during the day, and the variability of wind energy can be highly significant over the seasons. So analyzing actually the load duration curve, and after after subtracting the RE generation, we get the net energy curve. So analyzing what we see that the demand to be met in case of conventional generation for zero renewable energy lies in the range of 158 gigawatt to 225 gigawatt. But this curve, in the case of net demand, the range for conventional generation lies between 71 gigawatt to 215 gigawatts. So that is a huge range basically if you see the difference. And correspondingly, the ramping requirement of around 7,500 megawatt per hour for only 5% of the time in case of zero renewables, while this requirement amounts to around 21% of the time in case of 175 gigawatt of energy. These are the two curves, and in the second curve you can clearly see that the amount of ramping requirement increases for the 175 gigawatt requirement. So the generation from 160 gigawatt of solar and wind will displace the conventional generation. This is going to be issue for conventional generation, and this, other than that, sudden cloud cover or fall in wind velocity may affect considerably the plant load flows within the network. For this, to comprehend this challenge, gas power plants and hydropower plants, especially pumped type hydropower plants, will be required. But the availability of hydropower stations and hydro capacity development in future is restricted due to several constraints. Like for scheduling the existing hydro capacity, we are having the constraint of from agricultural point of view, irrigation point of view, and the future capacity development is also restricted due to the hydro capacity issues like geological issues, land rehabilitation issues, local agitation, environmental issues, forest issues like that. And regarding gas, we are constantly facing the issue of shortage of gas in the Indian power sector. Large capacity batteries, which are in the nascent stages of development, can significantly contribute in meeting the peaks. So the other part is the shortage of domestic gas. We have been facing unavailability of sufficient domestic gas for running the power plants. That gas-based stations is around 24 gigawatt. The gas supplied to the gas-based power plants was around 28.26 mmCMD in the last year. Imported LNG is an option, but it becomes uneconomical for them to get and dispatch. Around 53.56 mmSCMD gas would be required for balancing and peaking requirement of the grid by 2022 as per draft National Electricity Plan. So in the absence of gas, it is going to be an uphill task for the grid operator to meet the peak requirement along with maintaining grid stability and reliability. Other than that, thermal power plants would have to carry out retrofitting for increasing their flexibility and ramp up significantly, and that would entail capital expenditure on their part. So suggestions like advanced and precise forecasting of RES generation can be encouraged. Demand side management, like we can encourage the use of maximum renewable energy while the availability of energy is high and prices are low. And smart grid technologies using smart meters and effective communication technologies are required. Interconnection of grid at regional and national level is also to be improved. And focus on hydropower development can be very useful for offsetting this RES variability in future. You would also have seen this graph in the last presentation itself. So as per the graph, you are seeing that the PLF has been consistently has reduced significantly over in the 2022 scenario for different demand annual rates. So it would be around 21% of the total energy in 2022 of the total amount of energy required from RES. So correspondingly, the PLF of the thermal power plants would fall to a level of around 48 to 50%. Analyzing the possible reasons for this significant drop, rate of capacity addition has outpaced the rate of growth in demand in the 12th plan. There has been excess of capacity addition in thermal sector especially. The target was fixed at around 72 gigawatt, but the capacity addition achieved was around 91 gigawatt. The reason, one of the reason may be the delicensing of the thermal generation by Electricity Act 2003. Other than that, under construction thermal capacity of more than 50,000 megawatt has been under construction, which is likely to benefit by 2022. This additional capacity is going to further worsen out the situation for the existing power plants, and this may remain underutilized significantly. The peaking requirement in our low duration curve, if you see that, it leads to a dispatch of thermal capacities for small duration only, so that the peak demand can be met, as RE generation and the peak demand time duration does not coincide at all. So to comprehend this challenge, coal and lignite based capacity need to be flexible enough, because in this curve, as you can see, that the coal generation would drop to a level of around 30 gigawatt only and would be required to ramp up to a level of 110 gigawatt within a 6-hour duration. So that would amount to a huge ramping up requirement, and if we analyze the whole curve for the year, it comes out to be around 12,500 megawatt per hour for 10% of the duration within a year. So suggestions like the cost of coal-based generation may increase due to surge in the operation and maintenance cost. So to promote the flexibility and compensate for the loss and capex, suitable fiscal incentives needs to be provided. New tariff regulations need to be formulated by CERCs, SERCs in keeping requirement with the times ahead. So as we know that there has been a significant amount of capacity addition over the last few years, especially in the 10th, 11th, 12th plan. Corresponding to that, we have made large capital investment in manufacturing sector, and several joint ventures by international manufacturers have also been set up in India. Adequate indigenous manufacturing capacity, especially for supercritical equipment like 22 gigawatt for around boiler and 24 gigawatt for around turbine generator, exists in our country. But the challenge is the coal-based generation capacity required during 17 to 22 and the next 5 years is going to be nil. Other than that, there has been heavy investment in the areas associated to power plant construction, that is balance of plant. So what has been the challenge has been witnessed now also, that the several manufacturers have started reporting lack of sufficient orders presently. Capacity utilization factor for several manufacturing utilities is quite low. So this is going to render the manufacturing capacity and associated capital unutilized and may add to the burden of banks' balance sheets. The future scenario for these utilities, if we analyze that, so the focus of Indian government is going to continue for the development of RES, that is beyond 22 also, as India has to comply with its INDCs. There has been demand projections by 19th EPS, and those projections also do not create a very rosy picture for the future capacity addition from thermal sector. So the requirement of no additional coal-based capacity in imminent future is going to deal a severe blow to the large manufacturing base which is existing in India. So to tackle that, incentives for exports in the form of tax benefits, subsidies may be considered to boost the existing manufacturing base. The next challenge is implementation of environmental norms and phasing of retirement. This has been in news in the recently as India has committed to reduce its emission intensity of GDP by 33 to 35% by 2030. So to achieve that, installation of FGD systems has been made mandatory by December 2017. But this technology installation requires heavy expenditure of about 0.5 crore per megawatt. Thermal power stations have been deferring this capex as they would be rendered uncompetitive due to this additional cost of expenditure. Regarding that, no regulation has been framed till date for this additional expenditure on the part of FGDs. Also, there would be huge space requirement for installation of FGDs, storage of limestone and gypsum, additional water requirement, and limestone source identification. This has been opposed, the retirement has been opposed by several state utilities also, as it is going to affect several of its stakeholders. Critical issues for the utilities would be that manpower employed in such projects would be rendered jobless, and shutting down the project would also affect the local economy and would face the local agitation, as every project thrives the local economy in the surrounding areas. So disposal of scrap is also going to be a challenge, because that would lead to huge amount of scrap also. Other than that, maintaining grid stability has to be ensured, because in case of high retirements, there may be disruptions to maintain the peak requirement and meet it. So it has been estimated that around 34 gigawatt of capacity shall be retired in the coming years, but as per the latest assessment, this figure has been reduced to around 17 gigawatt only. So retirement at this large scale is also going to affect the power procurement plants of the states, and it is also going to burden the finances of the state if new capacities are planned in place of these old inefficient ones. So suggestions like phasing out of units over the coming years shall be carried out in a manner that causes minimal disturbance to the grid, and it needs to be ensured that sufficient new capacity is commissioned before the units are retired. The people rendered jobless may be rehabilitated and provided training to be absorbed in generation capacities likely to benefit. So the last but not the least challenge, the large-scale disposal of energy storage devices. As we know that the batteries are going to be quite useful to compensate for the variability of RES generation. Handling and recycling of batteries is governed by Battery Handling and Management Rules 2001, and this rules mandates that for the manufacturer they must recollect 90% of the batteries manufactured by them. But the compliance of these rules is in very dire states. So for the lead batteries, lead recycling industry is very nascent stage in India. Economies of scale has not been achieved till date, and the cheap and polluting technologies are thriving through small operators. Backyard smelting of used lead acid batteries is very common, which leads to environmental hazard and jeopardizes the health of the workers working in those recycling utilities. So in the coming years, with the onset of electric vehicles and solar rooftop installations, battery use would be more widespread. So recycling facilities of ample capacity is must in the future years. Lithium-ion batteries are getting quite popular among the manufacturers because of their higher capacity and ease of handling. But the recycling process of lithium-ion batteries is more complicated, and economically viable technology for lithium-ion batteries is still under development. So lithium-ion batteries also can went into wrong recycling streams due to lack of awareness and regulations. Suggestions like suitable methodologies need to be devised for segregating and recycling lithium-ion batteries, And formulation of regulations for disposal of batteries in an environmentally and economically sound principles should be evolved. And in this regard, labeling of battery components by means of barcodes, RFID chips, etc. can be quite useful. And incentives can be provided for good recycling practices and penalties for the bad ones. And other than that, incentivizing the customers to surrendering the use of used batteries can be a good step forward. Thank you.